Everyone, today our group would like to present about network analysis and critical path method. Okay, this is our group. I will present my part about definition of network analysis. Network analysis can be defined as the study of network structure, relationship, and behavior. It can be useful in different applications, such as understanding changing natural phenomena, social network relationship, most efficient routes of transportation, key influencer and biological system analysis. Definition critical path method to produce an accurate project schedule. Project manager employ the critical path method or project management tool, the CPM method, also known as critical path analysis, and then consists of using CPM formulas and network diagram to visually represent the sequence of project tasks. After defining this task, part of sequence is duration is computed to determine the critical path.
Assalamualaikum and hello to all of you. My name is Muhammad Stakir Hamzah, metric number 2230391. Today I will talk about advantage and disadvantage of CPM, critical path method. The first advantage is stronger communication. Critical path method schedule require input from key players across all stage of project lifecycle, bringing together the expertise of various team members and subcontractors, from architects to electrician to construction manager, and make the schedule more realistic and robust from the start. The second advantage is easier prioritization. It means that identifying the critical path helps project managers clarify priorities and determine the plot of each task. The plot, also known as a slack, measure how long a task can be delayed before impact the completion date of project. The third advantage is improved accuracy in scheduling. The critical path method is a popular and reliable tool for improving the accuracy of project schedule. The fourth advantage is better risk detection. Critical path schedule make clear the relationship between dependent tasks so project manager can better predict the knock-on effect of a delay on the project. The last advantage is greater adaptability. When work does not go to plan, CPM network diagram give project managers the tool to quickly rework the schedule to fulfill the completion date of the project. The next one is disadvantage of CPM. The first disadvantage of CPM is complexity. CPM can become quite complex, especially for large projects with numerous tasks and dependencies. Managing and updating the network diagram can be challenging, and it may require specialized software to handle the complexity effectively. The second disadvantage is assumption of fixed activity times. CPM assumes that the duration of each activity is fixed and known with certainty. In reality, many project activities may have variable duration due to unforeseen circumstances, which can lead to inaccurate project scheduling. The third disadvantage is limited resource management. CPM primarily focus on time scheduling and does not address resource constraints adequately. If resource availability is a critical factor in your project, CPM may not provide sufficient insight into resource utilization or allocation. The fourth disadvantage is dependency on critical path. CPM heavily relies on identifying and managing the critical path, which is the longest path throughout the project network. If change occur on the critical path or if new critical path emerge, project timelines may be affected significantly. The last disadvantage is inflexibility to change. Once a project is underway and the schedule is set using CPM, making change to the project plan can be difficult. Modification may require a true re-evaluation on the entire schedule and potentially causing delays and increase on costs of the project. That's all from me on the disadvantage and disadvantage of CPM. Thank you.
Hi everyone, so for today I'm going to show you guys how to draw the network diagram for CPM. First, we need to take a look at the data or the question that we're given, which is here. Then, the final product or the final network diagram will look like this, which is it. You will gonna have a start and the end. Okay, so right now, how are we going to draw the network diagram is we need to take a look at the first activity, which is A. So we're going to draw A at start. Okay, and then for B, we need to look at the who or which is the immediate predecessor for B, which is A. So that's why we draw the B that connected to A. Same for C. C also got A as its immediate predecessor, so that's why we connected C with A. And that's how it goes. D connected with B, E connected with B, F connected with C, G connected with D, H connected with E and F, and after that, we're going to put it to the end. But for the times and days, we're going to put it as how it should be, which is 3 for A, for B, 6 for C, 6 for D, 4 for E, 4 for F, 6 for G, H for A. It is how it should be, and that's why the final product going to look like this. A with the times of 3, 4 with the times of B with the times of 4, C with the times of 6, and both of it connected with the immediate predecessor, which is A. And same with E, D, and E, F, G, H, and after that, we put it to the end. Okay, so next, my colleague is going to show you guys how to properly calculate it.
About calculation of critical path method, CPM. How to calculate early start, late start, early finish, late finish, and slack float. Use the CPM diagram and the estimate duration of each activity to determine their early start, ES, and early finish, EF. The ES of an activity is equal to the EF of its predecessor, and its EF is determined by the CPM formula EF equal ES plus T. T is the activity duration. Next, I will show to you guys the step to calculate the critical path. We have 5 steps I prepared to you guys. As you guys can see, first, obtain the project data, make a list of all the activity of the project along with their dependencies and their specific time. Second, elaborate the network diagram. We have written a post that explains how to elaborate the project network diagram step by step. Step 3, calculate the early start and late start times. Determine the early start and late start time for each activity. Step 4, calculate the early finish and late finish time. Determine the early finish and late finish time for each activity. And the final step is calculate the slack time. The critical path must be determined by finding out the slack for each activity of the process. The activities where there is no slack are the one making up the critical. For the example question, draw the activity on node AON project network associated with the following activities for Dev Carhart Consulting Company project. At the first column, we have activity. Second column, we have immediate predecessor. And the third column, we have time, days. The question is, how long should it take Dev and his team to complete this project? And the second question is, what are the critical path activity? For solution 1, the network diagram will look as follows. Forward path, we will now perform the forward path to calculate the ES and EF with an analysis of each activity. Start node, this dummy node has all values equal to 0. For activity A, EF equal ES plus activity time. EFA equal to 3. It is obtained by adding the ES with the duration of the activity. For activity B, EFB equal to 7. It is obtained by adding the ES with the duration of the activity. For activity C, we can see EFC equal to 9. It is obtained by adding the ES with the duration of the activity. Next, for the activity D, EFD equal to 13. Our next calculation to find activity E, EFE equal to 11. And activity F, EFF equal to 13. For the others activity, we can find using the same method. Finally, we calculate the slack for each node with the following formula. Slack equal LS minus ES equal LF minus EF. The final graph will look like this. The activity with zero float marked in red are the critical activities. In this example, these activities follow a single path that will be our critical path. A to C to F to H. Total project time is 21 days.